Good morning, dear students. Welcome to the last session of generic digital switching system model. So in previous sessions, we went through the introductory part, then hardware architecture, software architecture, recovery strategies. Then we discussed a simple call through a digital switching system and its relevance to intra IC and inter IC calls, line to line, line to trunk, and trunk to line line calls. So that is what we discussed up to now. So now let us discuss the last parameter related to the digital switching system model. So in this, what are the some common characteristics of a digital switching system? Now the first characteristics which comes to mind is dual capability. So what does dual capability imply is it should have both the capabilities, for example the handling the incoming and handling the outgoing facilities which are provided to the customers. So in short, if we specify, they have the tandem or toll capabilities. That is, it should be acting as a tandem office or toll office as and when required. That is what it specifies. Then there is some termination capacity which is involved with the digital switching system. So that is generally the termination capacity is around 100,000 lines to 60,000 trunks. So that is the termination capacity or capability which has to be present for a digital switching system. Then there should be a traffic handling capacity related to the digital switching system, so based on which the entire design will be looked after. Generally what parameter we looked for traffic capacity is generally a digital switching system should be having around 200,000 say busy hour call attempts. So this should be as high as possible. Then next comes the architecture hardware, that is whatever hardware architecture we had discussed previously. So it should adhere to minimum those facilities which we have discussed. Now here another parameter to look forward is generally the architecture is quasi distributed hardware architecture. So what is meant by quasi distributed hardware architecture is basically we can have first two kinds of architectures, that is one is central and one is distributed architecture. So in central architecture there is one important component which will be say handling the entire system. Now in distributed architecture what happens is the capability, the instead of one person handling or one system handling the entire system, what we do is we divide that work amongst multiple components or multiple softwares. So this is what the distributed architecture implies. Each of them are having their own advantages and disadvantages. For example, if I just speak of centralized architecture is easy to maintain since only one component will be handling the entire thing, either software or hardware. But if something goes down, then the entire system goes down. This is the disadvantage. So that can be overcome in distributed architecture. And here, since we are going for modular approach, maintenance also becomes easy and identifying the faults also becomes easy, whereas in centralized architecture it becomes very difficult. So now what we do in the architecture related to digital switching system is we try to take the advantages of these both and build the architecture. So I can have at some points we can have a centralized architecture by looking into the advantages what will be provided at that location, and at some points we can have the distributed architecture. So the architecture will be compromise between the centralized and distributed architectures. So that's why the architecture hardware will be quasi distributed hardware architecture. So next this thing is multiple processors can be involved in such kind of architectures, so which will be basically acting as a subsystems. So next comes the architecture software. Again, as we had seen previously, that in software architectures we have different levels of architecture, like system level architecture, which is further divided into three parts, that is call processing software, then We have maintenance software and the network software, which comes then again. Call processing software is divided into again network software and the peripheral softwares, so which are interrelated. Basically we try to follow those characteristics which are involved. So here if we just observe, we have divided the entire model work into multiple things. For example, maintenance software will be looking specifically for maintenance. Call processing software will be looking specifically for call processing aspects. So what we are basically doing is we are dividing that work and trying to extract the entire operation. So this is basically a modular approach what we are using. So basically the software architecture refers to the modular software design. So it intends that divide and rule policy. You divide the entire work into small chunks and work on the small chunks so that the entire big work can be done out. Now all support database systems of office records, subscriber records, translation data, administration data, etc. has to be maintained in this software. So this is another architectural feature what we have to look out. And all of the softwares what we are speaking should have its maintenance facilities available with them. Then apart from this, billing systems also have to be supported in the software which is required for billing the customers. Then comes the switching fabric. So here if we just look at the characteristics, these are nothing but what all components and what all softwares we have seen in previous slides. The same thing I'll be reflecting here. So next comes the switching fabrics. So as I specified in previous case, that switching fabric basically utilizes time, space and time switch mode to establish a connection between the two customers, that is a called customer and a calling customer. Then next, remote operation. So remote operation facility also should be available. That is, suppose I want to access something remotely, then these facilities have to be done. So this might be used for purpose of remote diagnostics. So instead of going to the location itself and trying to identify and wasting the time, can I debug that problem sitting at this location itself, at a remote location itself? So for that you should have remote switching modules. Then apart from that, there might be some advanced feature support. Now if I in the previous slides also I mentioned few important parameters such as ISDN and AIN, which is advanced inter network, and ISDN integrated services digital network. So these are the things what I specified. So here previously we could understand that telephones were utilized only for calling purpose. So it was a message switching aspect which was involved over there in order to establish the connection. But later with the advent of computer networks, we came across features such as packet switching and ISDN networks and AIN and other stuff. So now the same telephone network and the telephone devices, if they are capable of enough, or if they are they can support these additional features, such as the packet switching feature, or if they also support feature which are related to ISDN or AIN, then that will be an added advantage, so which can add as a extra characteristics to the overall digital switching network. Now since digital aspect comes into play, and if a computer is involved, computer deals with the data in digital form, so we have to have some mechanisms in order to handle that digital information. So those are the things what advanced feature support can be looked forward, which can be provided by the entire digital switching system software, that is AIN, ISDN, then packet switching and other stuffs which are related to computer networks, and again in turn they might be related to the digital services which might be provided. So this is all for this module. Let us wind up this entire module in this session. Thank you and stay safe and stay away from COVID-19 by staying at home. Thank you.